Okay, let's just dive right in. Today we're going to talk about two absolute superpowers in the Java programming language. First, how to write code that's way more efficient by reusing it, and second, how to build programs that are tough as nails. Able to handle errors without just crashing. If you've spent any time coding, you know this feeling. You know the drill, right? You write this really clever piece of logic for one part of your app, and then, a little while later, you find yourself writing pretty much the exact same thing for another part. It feels repetitive, it's super inefficient, and man, it is a nightmare to maintain.
And then there's the other side of the coin, that heart-stopping moment when your code, which was working perfectly, just doesn't. An unexpected bit of user input, a file that's missing, maybe a division by zero, and the whole thing just grinds to a halt. So how do we tackle these two massive common headaches? Well, let's start with the first one.
To solve that endless repetition, that copy-paste problem, Java gives us a really elegant solution called inheritance. And honestly, the best way to get your head around it is to think of your code like a family tree, where abilities and traits get passed down from one generation to the next.
So what is it, technically? Well, inheritance is basically when a new class, we call it a child class, gets to take on all the characteristics, all the variables and methods from an existing parent class. It is the absolute definition of the write once, use many times philosophy. You create one solid blueprint, and then other classes can just build right on top of it. The whole thing really hinges on this simple but powerful idea called an is-a relationship. For example, it just makes sense that a programmer is a type of employee. So the programmer class can inherit all the general stuff from the employee class, like having a name or a salary, but then it can add its own special skills on top. And the magic word in Java that makes this all happen? It's the extends keyword. And why should you care? Oh, the payoff here is massive. For starters, you're not rewriting the same code all the time, which saves you a ton of time and effort. It also forces you to keep your projects clean and logically organized. And maybe best of all, it unlocks this really powerful feature called method overriding, which lets you add some incredible flexibility to your code.
Now, in Java, this family tree can look a few different ways. You've got single inheritance. That's just a direct parent-to-child link. Simple. Then there's multi-level, which is kind of like a whole lineage. Think grandparent to parent to child. And finally, you have hierarchical, where one parent class can have lots of different children all extending from it.
Now, what's really interesting is this brings us to a point that trips up so many developers. The difference between method overriding and method overloading. They sound alike, but they're totally different. So overriding, on the left, is all about that parent-child inheritance we've been talking about. The child class provides its own special version of a method it got from its parent. Overloading, on the other hand, all happens inside one single class. It's where you have multiple methods with the same name, but they just take different inputs. It's about flexibility within a class, not between a parent and child. Okay, so we've used inheritance to make our code efficient and clean. That's awesome. But what about making it strong? What do we do when things just inevitably go wrong while the program is actually running? This is where we run into something called an exception. Now, it's really important to get this. An exception isn't a bug in your logic. It's a curveball. It's an unexpected event that happens at runtime and just completely disrupts the program's normal flow. Think of it as a problem that needs to be handled gracefully. And trust me, these exceptions are everywhere. You've definitely seen them. There's the classic arithmetic exception, when you try to divide by zero. A big no-no. Or the dreaded null pointer exception, when you try to use an object that just isn't there. And of course, array index out of bounds exception, when you try to grab an item from a list that doesn't exist. Now, if you just leave them unchecked, any one of these exceptions will crash your program. Flat. Game over. So instead of just letting our code fall off the tightrope, we need to build a safety net to catch these errors before they do any real damage. And in Java, that safety net has a very specific name. It's called the try-catch-finally block. This is a structure designed for one purpose and one purpose only: to anticipate and handle those runtime errors without bringing your entire application down. So, the crucial point is how these three parts work in perfect harmony. First, you take your risky code, your high-wire act, and you place it inside the try block. If something goes wrong in there, the catch block immediately acts as the net. It catches that specific exception, and then you get to decide what to do about it. And then you have the finally block. Think of this as the cleanup crew. The code in here will run every single time, whether an exception happened or not. It's perfect for things like closing files or database connections. And here's the full toolkit. So beyond try, catch, and finally, you also have the throw keyword. That's for when you want to create and trigger an exception yourself. And then there's throws, which is basically a warning label you put on a method to tell other parts of your code, hey, be careful, this method might cause an exception, so you better be prepared to handle it.
All right, let's bring this all together. Here's the big takeaway. Inheritance, that's your tool for building efficient code through reusability. Write less, do more. Exception handling, that's your tool for building resilient code by gracefully managing errors. When you truly master both of these concepts, you're not just writing code that works, you're writing smarter, stronger, and way more professional software.
So the question I want to leave you with is this. Now that you have these tools, these superpowers of reusability and robustness in your toolkit, how can you start designing software that isn't just functional, but is truly elegant and built to last?